In this video, we are going to learn more about Bridgetek Eve Emulator. You can download the Eve MCU dev library from our GitHub page as shown here. In this case, we download as a zip file. We have a range of examples included to help you get started. Let's copy the simple example as a starting point for our scooter dashboard. Within the example, we have the different platforms that you can deploy to. You can easily add others too if you use a different MCU. The common folder holds the application code itself, which is used in the project for each platform. As we mentioned earlier, we will look at the emulator, the FT422 USB to SPI interface, and the Raspberry Pi Pico as an example of the MCU. First of all, let's try the emulator. We open the emulator solution in Visual Studio 2022. In the eveconfig.h file, we can set the Eve device to BT817 and the display to match our 7-inch 800 by 480 resolution panel. Here are the common files containing the simple application. And here is the target-specific layer of the library, which is for the emulator in this case. Here is the main example code. It still contains the simple example which we duplicated earlier. We can run it to see the emulator in action. A window opens running our example on an emulated BT817 based display. We see the Bridgetek logo and a counter in a custom 7-segment font. We simulate touch using the mouse and the counter increments. Let's replace the code in Eve example.c with the scooter dashboard code that we created using AI previously. We can copy and paste the code in to replace the simple example. If we run the emulator again, we can now see the dashboard running. The speed gauge combines a custom image with a built-in Eve gauge widget pointer. A custom font provides a large speed readout. A data array simulates the motion of the scooter in traffic. The touch buttons allow us to control the left and right headlights. We can now run the same code on the real BT817 kit over USB. We go back to our scooter folder and open the FT422 platform solution in Visual Studio 2022. We could edit the code here too if we would like, but let's run it now. We can now see our scooter interface running on the IDK development kit in the same way that we saw on the emulator previously. We can interact with the headlight buttons just like on the emulator. Perhaps the speedometer pointer would look better in red instead of white. Let's go back to the emulator and give it a try. Thanks to Eve's object-oriented commands, we can change the color of our pointer via a small edit to change the RGB color from white to red in just a few seconds. We can now run it again and see the pointer has changed to red. We can immediately go back to the FT422 project and run again on the real module to see how it looks there too. Here is exactly the same interface again, but now we have our speedometer gauge in red. We could go back and make many more modifications in either the emulator or the FT422 projects, but since we are now happy with the UI design, let's deploy to our MCU. If we go back to our main scooter folder, we can now open the Pico folder and open the workspace for the Pico. This opens in VS Code, which has the Raspberry Pi extension enabled. You could also build using the command line Pico tools. Once the workspace is fully opened, we can run a cmake clean followed by a compile. As with the emulator and FT422, we are building from the same eve-example.c application file from the common folder, and so our Pico code will have all of our updates. Once complete, the Pico tools generate a UF2 file. We have attached the Bridgetek MM2040 module to our BT817 kit. If we hold the boot select button when connecting it, we see the module appear as a storage device on the computer. We can simply drag and drop the UF2 file into it. A few seconds later, our application begins to run from the Pico itself independent of the computer. We could continue to integrate our application code, which reads from the sensors on the scooter via the Pico I/O pins and controls things like headlights, to produce our final product. We can of course go back and update and refine our design further in the emulator and FT422 platforms and then deploy again to our Pico. Likewise, if we decide to use a different MCU, we can deploy the code to that platform instead of the Pico. It's easy with Eve.